Introduction to gravity. Before we begin, I want you to think about what you know about gravity. Then I want you to go through a pretty straightforward thought experiment. We all know that penguins live in Antarctica, and that Antarctica is on the bottom of the Earth. So thinking about what you know about gravity, why don't penguins fall off the Earth? Obviously, there's something going a little bit different with gravity than we're used to thinking about. The definition of gravity is that it is the force that pulls a body towards the center of an object. For example, gravity pulls you towards the center of Earth, which means that being pulled down really just means you're being pulled towards the center of the Earth. Again, gravity doesn't pull things down, it pulls things towards the center. Another odd thing to consider about gravity is that anything with mass has gravity. Anything that is made of matter has gravity. That includes you, the Earth, the sun, air, a pencil. Anything with mass has gravity. So let's go back to our thought experiment. Why don't penguins fall off the Earth? Well, if penguins lived in the North Pole, this might be easier to understand. Because they would be pulled towards the center of Earth, which would look like they're being pulled down. But what if penguins lived over here? They would also be pulled towards the center of Earth. Their feet would be pulled towards the surface of Earth. Same thing if penguins lived over here. And finally, where penguins do live in Antarctica, they're pulled towards the center of Earth. Their feeling of gravity of being down is really just towards the center of Earth. Now, what can change gravity? Well, first off, it's important to know that gravity is the force that acts between all objects. In order to have a force of gravity, you need two objects. There's gravity between you and the Earth, but there's also gravity between you and your computer. The amount of gravity, the force of gravity, is really changed by two factors. The first is the mass of an object involved. Something with more mass, something bigger, will have a different gravity than something smaller. It's also important the distance between two objects. So again, gravity is influenced by the mass of the objects and the distance between the objects. So, if you have a mass increase, then the force of gravity increases. Things with big mass have big forces of gravity. And if distance increases, so if the distance between the two objects increases, then the force of gravity decreases. So let's go through some examples. In this first example, I have two bowling balls and two feathers. We'll represent the force of gravity with red arrows. First, just think to yourself, which pair of objects would experience more gravity? Which one would have a stronger force of gravity? Here's the force on bowling balls. Here's the force on the feathers. If you thought that the bowling balls would have a greater force of gravity, excellent. They would, because the bowling balls have more mass. There's more matter. For us on Earth, we tend to think of things with weight. The bowling balls have more weight because they have more mass. So they would have more gravity. What about this example? Which pair of bowling balls, the blue or the teal, would experience more gravity? Well, here's the gravity between the blue ones, and here's the gravity between the teal ones. If you said that the teal bowling balls would experience more gravity, yeah, excellent. They would because the distance is smaller. The blue bowling balls are spread apart, and so the force of gravity is less. The same thing happens with planets and moons. Here's the force of gravity between these two planets, and here's the force of gravity between the bottom two. The top two planets would experience more gravity because they are larger and they're closer together. Now, how does gravity affect orbits? To see how gravity and orbits are connected, we'll use a model. Here we're looking at a model of the Earth and the Sun. By clicking the play button, we can see the Earth revolve around the Sun. This is nothing new. However, in this model, we can actually model the force of gravity. So let's go ahead and put on the gravity so we can see it. You'll notice the blue arrows show the force of gravity. The Sun is pulling on the Earth is being pulled towards the Sun. You'll notice that the arrows do not change because the mass is not changing and the distance between them is not changing. Now, an obvious question might be, why doesn't the Earth simply get pulled into the Sun? If the Sun is huge, has a big mass, well, it must have huge gravity, which it does. So why doesn't the Earth get pulled into the Sun? And the answer is that Earth is actually moving in two directions. The Earth is being pulled towards the Sun, but the Earth is also moving perpendicularly to the Sun. Let me show you. The green arrow shows you the direction that Earth would like to travel in. It's trying to travel in that green direction. You'll notice that the green arrow changes as the Earth is going around the Sun, but the blue gravity arrow stays pointed towards the Sun. Earth is trying to escape, the Sun is trying to pull the Earth into it, and they've reached a balance. Earth is going just fast enough to not be sucked into the Sun. But we can play with this model a little bit more. For example, what would happen if there was no gravity? If I turn off the gravity, Earth still wants to travel in the direction of the green arrow. So if there was no gravity, Earth would simply travel in a straight line right into space. What if Earth was traveling a little bit slower? So we can make this green arrow a little bit smaller. Let's see what happens here. The Sun will still be pulling the Earth. The Earth will still try and be traveling perpendicularly. There you notice that the Sun's gravity was more powerful than the Earth's velocity. It's wanting to escape the Sun's orbit. And so the Sun did pull the Earth into it. What if we made the Earth go a little bit faster? I'll make this velocity bigger. Let's watch this one. In that case, the Earth was traveling too fast for the gravity of the Sun to keep it in orbit. So here you'll notice the perfect balance. The Earth is trying to travel in a straight line away from the Sun. The Sun is pulling on the Earth with the force of gravity, and there's a perfect balance between the two. The strong gravity of the Sun is exactly the same as the force of the Earth trying to travel away. Because of that, the Earth travels in a circular orbit. So here's your key ideas. Gravity pulls us down to the center of Earth. All objects create the force of gravity. You, me, the planet, the Sun, everything. Gravity is the force that pulls objects towards each other. Objects with more mass create more gravitational force. And objects that are further apart create less gravitational force.